Hello everybody! I welcome you all to this continuation for the keyboard project, the fully custom from scratch keyboard project. And today I have very good news, but before then, I have to do my sound check on my secondary device. Okay, it seems like the music is a little too low. I'm still trying stuff out with the music because last time I couldn't hear the music that much on my side while it was pretty high volume on your end. So I'm trying to hear it more on my side without you guys, hearing it like way too loud. So I'm just playing with this. Okay, I feel like it's pretty good right now with what I'm hearing on my secondary device. So today, I'm just going to present the objectives for the stream. Again, why again? Because, if you saw last stream, you may know that things didn't go too well last time, okay? I had huge problems with my setup, and I could not, for the life of me, compile the code for the Raspberry Pi Pico. Sorry, so I couldn't compile the code. I don't know why I couldn't. That being said, I could upload code that was already compiled to the Pico. So we did see that, I didn't break anything about the Pico when I soldered all the wires to it. So we did manage to use an old LED, debug LED blink example that I had. But we could not compile any changes to the code or anything like that. So since then, I did promise, it was 2 days ago only, and I had work in between, but I did promise that I was going to do a stream today, and I did promise that I was going to be able to compile once I come back to you guys with the stream. So I put a little boost in my free time. I pretty much did only that, almost. No, not just that. I did other stuff as well, but I did spend a good amount of time. And I am happy to say that I am now ready to show you guys what I've done, and I can now compile code for the Raspberry Pi Pico, and it's actually simpler than ever. Because what I discovered is I essentially restarted completely from scratch and tried to compile code as if it was for the first time. So I followed the guide, the official guide of the Raspberry Pi in the Getting Started PDF. By the way, I was using my downloaded version of the PDF, which was an old one. The new one presents a VS Code extension, official VS Code extension for the Raspberry Pi Pico, and it makes things so much simpler to set up. It's incredible. Like, genuinely, it's incredible. And that's what I'm going to be showing you guys. And I really feel like the music is too loud. Okay, I am going to make the music just a little less. Maybe like this. Yeah, maybe the music was a little too loud. Okay. That being said, oh yeah, so then like, I don't know, Google something. Okay. Now I'm ready to show you guys. So first off, I'm going to present the objectives. So today I'm going to show you guys a simple debug LED example. So it's going to be the blink default example. I'm going to then make sure that the button presses work. And by the button presses work, what I mean is the actual buttons that I soldered, so the switches. We're going to be doing a quick check for at least a couple of them. Maybe every single one of them, we'll see. Then we're going to be probably making some kind of like simple mapping, like very, very basic grid mapping to, yeah, I guess test every button. And then we're going to be trying to set up a simple, a simple USB communication with the computer to actually recognize the device as a keyboard, and then hopefully send actual like key codes to write to the screen. So hopefully today we're going to be able to at least, you know, even if they're not set up correctly, even if there's no layers or anything, just being able to send letters by pressing key switches. Okay, that's the objective, pretty much. And then if we can get to it, it would be really nice to start on the input analysis to transform them into like higher level inputs or events, as I call them. So I'm going to show you guys again my quick setup. Was it this one? No, it's this one. Oh, why is it so dark all of a sudden? Why is it so dark? Okay, let me just take a quick second. I think the webcam properties just reset themselves or something. No, not even. That's weird. Oh yeah, it did kind of reset. Okay, so like this, you guys can see. Apply. Okay. Okay. So that's good. So now you guys should be able to see the keyboard pretty correctly, or the half keyboard, as I would like to remind you. It's going to be a keyboard in two separate independent halves that are going to be connected with a wire. But for now, we're only starting with half a keyboard because we can treat it as a simple keyboard with a single Raspberry Pi Pico, no communication, nothing. Now, you guys can probably see my screen here. So there's a really cool, if I go in my extensions, there's a really cool official extension for the Raspberry Pi Pico, which is, what? Where is it? Pico? Why can't I see it? It's right there, okay? The Raspberry Pi Pico official extension. And what's really cool about this extension is, at least if you're on Windows, you don't need literally any dependencies. It's going to download the dependencies itself and put it in some folder on your computer. In my case, it's going to be in, like, if I go on this desktop. So, no, that's not. It's like in users, basically. So if I go in users and then my user, there's a .pico SDK. And if you go inside of this, you have SDK and then like versions and whatnot. Like, it's just going to download it by itself. So the first time you're going to compile a project is going to take some time. You know, upwards of 10 minutes, maybe a little more than that even. But it's because it's going to download all of the SDK you need, everything like that. And if you keep the same version of the SDK, it's transparent after that. You don't even have to worry where it's at. They're even going to set up for every project you create. You can create it using one of these buttons. So either new project from example. And in this case, you can start from the code that the example gives you. So, you know, there's probably one about USB communication or like tiny USB stuff. Is there one? Oh, is it unique board ID? I'm not too sure. Well, there's probably one somewhere. Not sure. Yeah, we'll see. Maybe we're gonna need it today, so that's why I'm looking, but you know, it's fine. And then it's just gonna set up the project as it needs to be. My board type is Pico, it's not Pico 2. And everything like that. But then you can also go new C++ project to get a C++ project going from scratch. And in this case, again, I'm just using the normal Pico. You give a project name, a location, and then you have a version of the SDK. I'm using the latest version. And then what's really, really cool is one of the things that was a little complicated previously is that every time you wanted to use a different feature, like you wanted to activate the UART, the SPI, you know, any communication protocol and whatnot, you needed to make sure to include in your makefile list, you know, the necessary includes and whatnot. But here you just check all the boxes that you need. And when you just create, your like in your project, the cmakelist.txt is going to be here, and everything is auto-generated for you. That's really, really cool. So yeah, it gives like pretty much everything you need, except maybe if you want to add other custom files. So here there's blink.c. If I wanted to add, I don't know, like a helper.c file, I would have to add it here, right? But that's pretty much, you know, off the top of my head, it feels like that's the only kind of modification I might have to do manually in the CMake list. So this extension is really amazing. And yeah, there's just a bunch of other options and whatnot. Like, it's very, very practical. I'm going to show you guys that I can upload code to the Pico. So right now you can see there's the Blink example right here. That's what's uploaded to the Pico. We can also see the Hello World project is something also that I did using the Pico. Like if I go, I'm going to show you guys. So Pico getting started. The current version is so good. So here, yeah, I think it's this one. So you can see it's in from chapter 2, you know, install Visual Studio Code. Okay, that's fine. Chapter 3, install the Raspberry Pi Pico code extension. Just follow this if you want to use a Pico at home. Honestly, it just works so well, especially if you're on Windows. Literally here, that's crazy. No dependencies needed. And it's true. It actually works. And then blah, 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 blah. Okay. You can follow that along at home if you want to do it. I'm not going to show you that, but you can go in a project. Oh, I guess I could. Yeah, I should open it directly. So here on my desktop, it's Pico official. Okay. So if I open VS Code directly in the folder of one of these projects, because right now I'm in the main folder containing both projects. As you can see, there's Blink and Hello World. So I'm in Pico official. But if I go directly in the Blink project and I start a quick VS Code, you can see in the extension, these buttons, they become available because they recognize that I'm in a project folder for one of the Raspberry Pi Pico projects. Music is not very loud. It's very hard for me to calibrate. But let's go like this. Okay, I hope the music is loud enough. In this folder, you can see there's debug project. I don't have the device needed for that, but there's compile project, which just works right off the bat. And run project, for me, there's a problem. It's not able to find my Pico. So even if I'm in, I think they call it boot cell mode, which is the mode where the Pico is ready to receive new code. It just doesn't work. So I'm still using my trusty do.bat. It works, and it does both operations in one, right? It compiles and then, copies code to the Pico, and it works, as it needed. Basically, what I really, really like about the Raspberry Pi Pico extension, it's really just the creation of a new project and the fact that they set up, the SDK, the tool chain, everything that you need to build, as well as the CMake list. Like, just doing that is fine by me. Then I can use the command line with my do.bat and my little commands and whatnot, and it just works. That's really, really cool. So now, let's just really quick show you guys an example where I can use the serial monitor to write messages to the screen on my computer. Okay? So basically, it's kind of like a console that you can connect to the Pico. So COM1, it's probably going to be another COM port, but you'll see. Okay, so let's put the Pico in boot cell mode. Okay, now it's ready to receive code. You can see it's not blinking anymore. And if I go ahead and I'm going to go from terminal. So, oh, I'm in the Blink folder here. So let's go here. Yeah. Okay, so here's cd ... I want to go in cd hello world. And then I just launched my do.bat. Everything compiles. And file is copied. You can see the Pico is still not blinking. It's fine. This project doesn't blink. Instead, if I go in serial monitor here, you want to make sure the baud rate is this. this was the default. And then COM4 is what the Pico is connected to. So if I go there and I start monitoring, you can see hello world is being written. So if we go in the code here in hello world.c, you can see I print hello world and then I sleep for a full second, 1000 milliseconds. So every second we're going to write this. Oh, why was it disconnected from the machine? That's a good question. No? This one? Oh, okay. I don't know why. That being said, it works. It's fine. We can do different projects. We can activate, you know, serial communication and whatnot. It's great. We're going to start with the serial communication here as a way to get information from the Pico and see how it's going. And we're going to start by testing if the buttons are correctly received by the... Okay, so these switches... Oh, it's very laggy in my webcam, huh? Kind of weird. Not sure why. Well, it doesn't really matter anyways. We're going to be writing a simple... Probably the most simple code you've ever seen in your life. We're going to do... Okay, wait. I'm just going to open really quick the Pico pins. What if I go in here? Pico pin. Yep. Thank you for this. I'm going to open like a new tab. Ah, come on. I just want the image. Yep. Okay, so here we soldered on GP2, the pin number 4, the first like letter of the Pico. So basically the little green button arrow at the left, that's the one. So let's say we go for, yeah, let's say we use that one and we write something to the screen when it's pressed. Okay, let's start with this. Very simple code. We should be able to do it. So the first thing I want to do is I'm actually going to take inspiration from my other, wait, here, Pico right there. There's a bunch of projects that I had here. Let's open them. Because we're going to be using code from those projects eventually. But let's say, test pin helper, and there's a module that I wrote. There's pin helper.h. But basically, I need, pretty sure, Pico standard lib. So do I have this in the other project? Yes, I do have it. And there's GPIO init, which is a function I want to use, and setdir as well. And GPIO in. So let's just take the code from there. Not the functions directly. Let's just, you know, do it raw dog it, you know, just like this. GPIO init, and this one we're gonna activate GPIO number 2, GPIO 2, and it's gonna be GPIO in to receive information. And then in the loop, let's say, yeah, every second, we're gonna do a quick if statement, and in that if we're gonna print only when the condition is correct. And here it's going to be what, GPIO. Do I see the... Nah, it doesn't say it. Okay, so what's the function to get it? Oh, it's GPIO get. Okay. Yeah, so we're going to GPIO get. So 2. And yeah, if GPIO get, so if it's true, basically, we're going to print hello world. Let's do it every tenths of a second. Okay, so now we should be able to recompile this and send this to the Pico. So, oh, also I'm printing, but maybe I can use the debug LED as well, right? Like this. Oh, no, no, no. That's not what. Oh, no. I don't want to write code like I do at work. Programming standards. And we actually also want to do this for pin 25, which represents the debug LED and is GP out actually. GP out. And then we want to write some code to, what was it? Perp, perp, perp. But yeah, GPIO put, and then, yeah. So that's what we're going to be doing. So for 25, which is the debug LED, it's not going to be true here. It's going to be 1. Okay. So now, when, like every tenth of a second, if we press this button right here, the Raspberry Pi Pico should see that it's on and then print hello world to the serial port, as well as turn on the... Oh, we're going to do an else though. And turn on the pin. The debug LED. Okay. Instead, if it's not pressed, then we reset the debug LED. Okay. So let's just recompile this and send it to the Pico. So let me put my Pico in boot cell mode. And then let's just send do. Okay, it seems to have worked. So now, let's try. Oh, does it work? Wait, let's go in serial monitor. And start monitoring. Okay. Oh boy. Doesn't seem to be working quite well, right? Okay. Maybe my soldering broke. That's a possibility. Or my code just doesn't do what it's supposed to do. How do we test this? Basically, we could probably try to... Yeah, we could probably just try to... Something like that. Okay, let's just really quick do a couple of them. Like, I don't know. Okay, maybe I just want to bring the H file from my... Can I bring the entire module thing from there? Like here, I have my modules. What if I just bring all of my modules like in here? Yeah, paste. Okay, do I need to add something to the CMake list? Probably, right? So that it sees the modules folder. Include. Yeah, okay. I'm very sure. Include directories. Okay, yeah. So that's good. But what if I also want to add? Maybe this. Slash dot dot slash modules. Maybe? Something like that? I can try. Now, what if I clean... Oh, I can't clean the thing. In Hello World build, let's just remove the CMake cache. And let's rebuild everything. And put my Pico in boot cell mode. Okay. Oh, did I break something? Okay, let me just... Here, in Pico official, in hello world, let's just launch the clean command here. Like right there. Let's just clean CMake. And compile. Will it work? Oh yeah, it seems to be working. Okay, so now if I relaunch my do.bat, it should work. Okay. Oh yeah, well, that being said, it probably didn't do much. So now that I have my .h files here, I think I should be able to include them here. So what if I try include, and then I'm gonna include, whoops. So is it pin helper? Pin helper.h. I think it should work. So here I should be able to do GPs in. So activate a bunch of GPIOs in input mode very easily. So instead of doing this here, I can just do GPs in. So we start at the first GPIO, which is going to be GPIO 2. And we go all the way to GPIO, it should be like 21 or something. Let's just check to make sure that I'm right here. GPIO 21. Yeah, I think that's it. I think it's 21. So now we activate all of them in input mode. And then GP get. Yeah, you know what? In pin helper, I could add a function to, well, not really. It's not very useful. But okay. Now let's add a loop in here. So something like for I try to put it like this. Okay, so like int I equals 0 as long as I is less than 20 plus I, and then what we're gonna do is we're gonna do like int, because we're programming in C, there's no booleans, so we're gonna go int you know, was pressed or something, which will be equal to 0. And if, so here we're gonna get yeah, is it GP on? No. Oh, we put here. Here we want to get though. So here GP get. Yeah, so if GP get, which is going to be in this case I plus 2, because the first one is 2 instead of 0. Oh, yeah, maybe I just don't do this, and maybe I just do like from 2 to 22. That's better. Or less than 21, I guess. No, not less than 21. Less than 22. Okay, so let's go like this. So if one of them then was pressed. Oh, I'm actually going to put that in brackets as well, because there's going to be 2 instructions. So was pressed will be equal to 1, which is great, and then we're going to break. So then it's going to be if was pressed, Okay, so we loop for, okay, we activate every single pin that corresponds to one of the switches on the keyboard. Now for every loop that happens every 10th of a second, we go through all of these switches, and if one of them is pressed, we, was pressed will become true, and then we stop looping, and we go here. So if it was pressed, so if I didn't go through all of them without finding one that's pressed, I'm going to write hello world to the serial port, and also put the debug LED on. Otherwise, I'm going to deactivate the debug LED. Okay, so now we can recompile and send this to the Pico. Let me just put it in boot cell mode. And let's just send it. Oh, I made a mistake. Expect before a while. What are you talking about? GP's in. Oh, I just forgot the. Yeah, okay, that's fine. Classic mistake. Let's send the code. Okay. So this one doesn't work. Oh boy. Okay, so I obviously made a mistake somewhere. Something's not working. Please don't tell me the Pico. Please don't tell me the solder is just completely broken. Okay, I think this calls for the multimeter. I'm just going to measure whether the current goes from, from the electricity to... Oh, wait. Oh, I think I have one reason in mind why it might not work. I connected everything to V6. So if I'm showing you the pins. So right here, pin 39, V6, like volt system or something. This one should be at about 5 volts right now. But maybe it's not for some reason. And if it's not, it would explain why no current is being received by the pins when I press the switches, because there's just no current going from there to the rest. So, let's just measure stuff. Oh, I don't remember. How am I supposed to measure stuff with the multimeter? Is it safe to measure voltage between 2 points that are not part of the same circuit? I don't think it is, right? Wait. Voltage. Or something like that. Oh, okay. That is what the AI says. Let's just see. How's the button rotate? Don't even connect in this graphic. Okay, yeah, I'm probably not supposed to do that. Okay. That stuff. Because I don't actually have a circuit going to the ground from V6. Oh, I know how I can do that though. I can take a resistance. I think on my desk. Still looking for the resistance. I don't know where to put it. well, well, well. Color me surprised. No, I don't know where. I have a bunch of resistance elsewhere. Try to get one. Oh wait, no, I have. Okay. I know where it's at. I have a bunch of resistance here. On a breadboard. So here, I take a resistance. I don't know if you guys can see. And I'm going to be disconnecting the crocodile crimps from the button here. And I'm going to be connecting them, like making a circuit with the resistance in the middle that goes from VSys. So again, if I show you guys, from VSys to a ground. So maybe that ground right there, or maybe another one. It doesn't really matter. This way I'm going to do a loop. And all of the voltage is going to be consumed by the resistance. And I can measure on both sides of the resistance what the voltage is. It should be about 5. We'll see. Yeah, so I'm getting 4.7 volts or so. So yeah, it seems like there's current. Well, it just seems like there's voltage in the VSys as it should. So I'm not too sure what I'm supposed to do at this point. I can use my multimeter as well to make sure that the points are connected. So I can, what I did after soldering to make sure it worked is I would connect my one side of my multimeter to like VSys, like it is right now, and the second one I would connect to the I would put myself in resistance mode, by the way. So measuring the resistance of the circuit, which would be like a full 1 when it's disconnected. And then I connect myself to like a pin after that. And once I press the switch, the resistance should, you know, drop from like full resistance, like infinite, to something like a, you know, like 6 ohms or something, or 10 ohms. Just like a very small resistance. So let's just try this and see if my circuit broke or something like that, or maybe the problem is something else. We'll see. Well, well, well. Would you look at that? You guys probably can't see the crimps. If I just turn this around a little bit. Oh, it's really hard to see with the webcam. Let me just move that out of the way. You guys can probably see. By trying to measure the resistance, I ended up making a circuit that connects VSys to one of the pins. And would you look at that? We can see that the debug LED is turned on, so the code works. And if we look here, yep, hello world is being written every 10th of a second. So it works, the code works, and it's uploaded to the Pico and everything. Now, the biggest problem that I have, or bigger problem, I guess I should say, is that I don't know why, but it seems like my buttons or my switches, they don't work right now. Why? I have no idea. If I show you guys my multimeter, 1, full resistance. Okay? So if I press the button now, so the very first button, oh boy. Yep. Full resistance again, even when I press it. So it means, I hate this. It means probably when I closed it off or something, I must have broken one of my solder and whatnot. So the circuits, they're not closed anymore. Like, they just don't work anymore. Oh boy. You know, it's fun doing embedded programming and
Hello, hello, hello. Okay, you guys can hear me, right? Yo, this is so weird. I had a message in Windows saying it had some kind of power surge, and now the light on my microphone is just deactivated. I hope there was no problem. I'm pretty sure the power surge thing was about the Pico, because I probably had some short circuit going on. Okay, well, anyways, so we're about to measure the voltage coming out of the 3v3 pin. So if I show you guys again, it's that pin right here, 3v3 out. We're gonna measure that. So it's the fifth one. Okay, well, I think we've got our answer. My solder are probably correct. It's just that the 3v3 out, which is supposed to output 3.3 volts, somehow it seems like it's not outputting anything. But again, maybe I need to write a line of code to activate it. So if I go Pico, I don't know, like SDK documentation, something like that. Pico CSDK, yeah, okay, the data sheet here. Yeah, here. What if I go... Wait, is it? Hello? Yeah, I don't know. Something's really weird with my mic right now. My filters aren't on and everything, and like the sound is so strange. And I really need to check stuff out afterwards. Like that power surge was crazy. Okay. Well, anyways, that being said, let's just try to see if I control S. I don't know, like 3v3. No. 3v3 out. Yeah, okay, cool. Wait, the first one is just an example configuration file. Okay. I don't know. GPIO 15 with 3v3 out. Pull up resistor about 4k ohm. Oh, is that it? Need a pull up resistor. but it doesn't mean anything. It's for what? It's for a project again? It's for the... Okay. Not much information. If I go something like RP 2040, I think it's data sheet called, yeah, this one, maybe. So if I go 3v3, the word is not even there. Oh yeah. What? What is this? Voltage select register? Oh my god. Yeah, it's still a little too complex for me. Nope. If I say Pico use 3v3 out. Okay, yeah. What are they talking about? Okay, yeah, that's what I want. Yeah. Okay. I mean, it doesn't say anything. Like, I measured and there's literally no voltage here. I feel like I'm going crazy. Okay, yeah, I'm just gonna write my problem instead. So, if I say no voltage on 3v3 out. 3v3 pin number 1 not giving output. 3v3 pin number 1. I don't... What 3v3 pin number 1? Do you mean this one? Or... Okay, let's say it's this one. Let's say it's just value. Not giving me the voltage. Yeah. Okay. What's wrong? Are there any issues with the other? Pin 1 and pin... What pin 1? Here? Oh my god, what are they talking about? Oh, it's a normal Raspberry Pi. Oh. Yeah. Pico 3 issues when connected via USB. Okay, that seems to be my problem. It drops to, okay, sure, but I don't even have voltage at all. Well, that's kind of annoying. You know what? Just for the sake of testing right now, like using my code, I can probably just connect my 3.3 volt out to my VSys, which actually contains power. Oh, oh, is there no music anymore? Well, let's try this. Oh, I disconnected the PN. Oh wait, did I not reconnect when I tested the voltage? Yeah, that's what happened. Okay, let me that was so stupid. Let me remeasure the voltage of the 3.3 volt out. .26. Would you look at that? Now I'm gonna make sure that the buttons aren't the problem by measuring if there's any resistance between the pins that are supposed to be receiving current from the buttons and the 3.3 volt. Okay. I don't see a reduction in resistance, so basically infinite resistance at all times. Meaning that I probably broke the circuit, actually, after all. So, kind of heavy, but I'm gonna have to reopen it and see what's up. So now that it's open, let's just see what the problem is. I found one place where it's disconnected. Found a second place where it's disconnected. On a third place where it's disconnected. On fourth disconnected. Okay, we're going to be doing a bit of soldering. It's unfortunate, but that's how it is. Eventually, the project is just going to work. Eventually, the soldering is going to be behind us. Okay, well, the soldering iron is getting hotter. Okay. Webcam's moving. Kind of a crazy setup. Unfortunate that it didn't work. Because as we saw when we connected things with the crocodile crimps, like the code actually worked. So. But at least the setup works. I can write code, you know, it works. We can send information via serial forward. So that's really, really good. If I can solder real quick and it can work immediately, we can still make a good amount of progress. Okay, I think the soldering iron is hot enough, so I can try to start soldering. This as well. Really? Okay, that's solid. Sorry guys, it's really hard to show you what I'm doing. I'm just not set up very well for soldering, but I wasn't supposed to do any this stream, so sorry for that. Okay, that solder's pretty good, but I'm afraid I just soldered the other wire as well. Okay, so I fixed the thing I was afraid of. I don't even know if it was a problem, but I'd rather just fix everything right from the get-go. Okay, I disconnected something while moving a wire. I'm just gonna resolder that as well. I think I'm fine now, but I'm just gonna check that I don't need to solder anything more. And if not, we're gonna try to close very carefully the case. Oh, there's a connection I forgot to solder. I didn't notice at first that it was broken before I even started. Okay, I think everything's fine now. And you know, if there's broken solders and whatnot, it's fine. It's really just the main current receiving circuit. It's kind of important that it's not broken too early, because some of the keys should have worked, by the way, before. If I've actually managed to fix the problem. But I guess I didn't test those very easily. Because the ones receiving the power are in the middle, like right here. Oops, like right here. And these, yeah, they were receiving power, ostensibly. So now I'm gonna try to close off the case and get back to the code. So let's go. Okay, I closed off the case. Now let's just redo my quick setup. Have to be careful because the soldering iron is still kind of hot. Okay, so now I can reconnect the Pico. Like this. Okay, so let's try. Oh yeah, but there's the whole thing with the USB power surge that's giving me trouble. I don't know how to reset like my USB connection. Hmm. I'm gonna try to connect it to a different USB. Wait, I just wanted to try something. Oh my god, okay. Yeah, that's what I thought. So, I understand why my microphone sounds weird. It's because I'm not even speaking. Where is the microphone? Oh, is it here? Hello? Hello? Oh, is it that one? It might be, I don't know. Or is it next to my webcam? Hello? Hello? Yeah, I think it's the webcam one. Oh, I can actually try the one from my headset. Oh, okay. It doesn't seem to be working too well. I think it's still the webcam mic that's being used. Okay, well, sorry for the echoey sound. Or is it this one? Oh, is it using the correct one? That's confusing. Okay, well, in any case, I don't currently have like power in my USB. I don't think so. Like, I don't know, maybe some of them are still activated. Let me just try a couple of them.
Oh, I think I got it. Yay, my correct microphone is connected. Woohoo! And my filters are still there. So now the sound should be okay, I guess. Let me just check with my second device. That being said, the Pico as well, I heard a sound when I connected it. So it should be... Is it in boot cell mode? No, it's not. So I'm just going to do that. Yep. It's in boot cell mode. Okay, so now let's go. We're back. We're so back. Do? Whoops. Do? Okay. I really hope it works, man. I really hope it works. Oh, come on, man. I don't get it. I guess it's still my solder, which is not okay somewhere. Is there a short circuit? Did I solder two things together that I shouldn't have? Ah, that's very annoying, actually. That is very annoying. Damn. That's sad. Let me just try to short circuit again. Wait, did it? Did it put the Pico in boot cell mode again? No, it didn't. Okay, that's fine. Oh, wait. No, I think I did. Put the Pico in boot cell mode. No, I still didn't? That's crazy. Okay, I keep hearing the sound of the Pico, but it's still not in boot cell mode. That is so weird. Oh, wait. It was incorrect. I think I did not upload the code correctly. Possibly. Let me just give me a sec. Now it should be in boot cell mode. Yes, it is. Okay, so I can just send code. Let's just do it one more time. Okay, so code is there. Now I can test. Huh, it doesn't seem to be doing the same thing as it did earlier. And if I check the serial monitor? Oh, the COM port is not even connected? Okay, it probably means that the code is not correctly uploaded to the Pico. Weird. Let's try to upload the code normally. Okay. And that's the code. So if I just send it now. And it did copy it. And now the Pico is not there. So, okay. Okay, not sure why. Did I break something when I soldered it? Hope not. Let's try, okay, just to make sure that the Pico still works. How about we try to like if one or something. And then here instead it can be every second or something. Okay. 2. Okay, well, there's a bit of a problem here. What about I go to Blink instead? And upload that code. Okay. And then I write do. Okay. So Blink works. Blink works. So far? Okay, let's just put that into into a comment. Oh, wait. Yeah, it's true. Here, I need GP out. 25. for the debug LED to work. Okay, let's still put that code in comment. Let's go incrementally, okay, to make it work. Okay. No, that's not correct. Oh yeah, because I did do in this. So cd hello world. Then send the do to the Pico. Okay, so it's constantly on. That's good. That's a good thing. Oh, come forward's connected now? Oh, there's a bunch of hello worlds. Oh yeah, okay, because because this. Okay, so that's good. That's good. So now if I uncomment this and use this condition here, will it work? That's the question. So let's re-upload the code. Okay, and now if I press. Okay. This doesn't seem to be working very well. And there's obviously going to be like nothing on this COM port. Okay. Let me just try something. Something is wrong with my circuit somehow. There's somehow a problem. What could possibly be the problem? Oh, I might have an idea. Oh no. I just thought about that, but yeah, that might be the reason why sometimes. That was for other circuits, but you know, sometimes we see like a pull-up resistor. Yeah, I think that what's happening is that there's a bit of resistance along the way in my circuit, and somehow the voltage like doesn't follow. Like somehow the because basically my circuit doesn't go to the ground like ever. So it goes from power to another point, but that point, maybe it's not going to be considered at a certain voltage, right? Maybe it's just, I don't know. Maybe I need to pull up resistor is what I'm thinking about. Let me just measure voltage in the circuit. Let me just try that. Oh, by the way, while I'm measuring, like a prime moment for a little bit of ambiance. So I'm just making sure you guys have music. Okay, so let me just try to find like that first one, that closest, the first one that's receiving current. If any should work, it's that one, the G. So it's number 6, 7, 8, 9, 12. It's number 12. So if I go on the Pico thing, where's the Pico image? Here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it should be 4 from the bottom on that one side. Yeah, either it's not connected because the voltage difference is 3.26. Either it's just not connected, or it's simply that just the wires of the circuit are enough to count as like full resistances. So but that's kind of weird. I don't remember using pull-up resistances in like my normal circuit. Not my normal circuit. I mean, in the circuit that I used for that's so weird. Well, not sure what the problem is. I'm really gonna need to check inside the case. I'm pretty sure. Now, if I connect stuff directly using my crocodile crimps, as you guys can see, if I connect them with the crocodile crimps, I do get the behavior that I want. Okay, so I guess for now, we're just gonna leave aside everything that's to do with the internal circuits. I'm really gonna have to check them on my own side, maybe add some pull-up resistor that go to the ground or something. Maybe, I don't know, we'll see. In the meantime, what I'm gonna be doing is, because I really just want to write some code now. I'm kind of tired of dealing with that. So, oh, also it's cool. My pin helpers work. So my modules seem to be working, which is really nice. So I have a bunch of modules. That's really cool. The debug LED as well. So there's debug LED init and debug LED update that I have to call every loop, and debug LED set interval. Oh, by the way, debug LED set interval. I guess I should probably put it in the init as well. Yeah, let's just add real quick this. Just a function where I can init with a U32 interval. Whoops, like this. U32 interval. And then here I can call set interval. Now like this. Or I guess. Basically, that debug LED module, it's a module that I wrote to make the debug LED blink at different rates easily. So basically, you just call debug LED init, and now I just added a overload of that function where you can already just set the interval in the init call. And then you just call debug LED update for every loop. So like at first here. So for example, if I include something like debug LED.h, I can just call here. It's going to be debug LED, not set interval, debug LED update. Like this. And I can just, you know, LED init like this. And I can just add a delay if I want to. So something like, I don't know, like, oh, how long is this? Pretty short, huh? Okay, so let's just remove all that code. Make this simpler. Let's do this every second. Debug LED init with like 500. So every half second, the debug LED is supposed to blink now. Let's just see if it works. All right. I really need more crocodile crimps because I only have one red and one black, and I try to reuse them for like so many applications. Okay, like this, and now do. Oh, there's a problem. BSP board, no such file or directory. Where? Why? Really? BSP board.h? Why not? Pico standard lib and whatnot. Why did I need that already? So if I go in pin helper, I don't use it. Oh, I see. In debug LED, I actually don't. It's in something else. So I call pin helper as well as timer, and types. So in types, okay, there's nothing here. And yeah, it's just to be able to have like types of different sizes, but that's not that useful. And then timer. In timer, I do use bspboard.h. Why can't I find it though? That's strange. What if I try do again? Yeah, why doesn't it find it? That is strange. It was to get board milliseconds. I'm not too sure. In the CMake list, I'm supposed to be including stuff. What if I go create new project? Maybe I forgot to turn on something when I was in new project. I'll just say Pico. Oh, is it hardware clocks? Or hardware timer or something? I'm not too sure. I can research. So... how's it called? Again? Called... No, not here. Oh, whoops, I'm in the wrong one. BSP/board. Yup. Okay, so it seems like it's a tiny USB thing. BSP board. Apparently. Meaning that I probably needed to activate something. Where do I activate tiny USB, by the way? Oh, you know what? Let's just... Oh, no. See, you can't now, from example. How do I... Yeah, if I do... Because with the new setup, I don't know if there's an example project that uses tiny USB. So let's try to find that. So, Pico... Getting started. Let's just try. Like this. And I can just try to find tiny USB. Nope. If I go Pico examples... in that directory here, is there nothing that uses tiny USB? Oh, there's USB for sure. And in USB, yeah, there's a bunch of stuff. So I should be able to create a new project based on the examples. So how is it called? I probably just need to have the name correct. So there's, let's say like USB device or something. Yeah, how's it called? Yeah, okay. USB. There's like USB in a bunch of places. Oh, Dev HID Composite. It seems like that's the name of the project. So let's see. Is there something like that? I really wish I could make this drop down a lot bigger. But, you know, that's how it is. Oh, Dev HID Composite. That's good. Okay. So here, let's just create that project and see how they set things up. Okay. Oh no, come on. I deleted. Okay, wait. Give me a quick second. Official. Open this. That's fine. Okay, so here in the Dev HID Composite. Okay, it's gonna be way more complicated with the descriptors and whatnot. The config, everything. It's a lot more complex. Board/board API.h. Descriptors, and in these files, what do they include? I'm not too sure. Okay, maybe the name is just different. BSP/board API instead. Not sure if all of the files exist. Wait, can I? Like, I don't know. Okay, the CMake list. What do they add to the CMake list to make the tiny USB functionality like exist? Yeah, okay. Okay, yeah. Add execute, that's fine. Target sources, that's fine. Include directory. Okay, yeah. Oh, target link libraries. It seems like that's the difference with mine. So I can probably just add something in here in the target link libraries of my project to have access to this. So something like, oh, it's probably tiny USB board, right? Maybe I just take it all. Maybe I just take all of it. Let's see. In Hello World. Target link libraries. Yeah, I really don't have that many. So something like that. I don't know if the keyword public is necessary. Let's say it is. And let's go like this. I don't want to duplicate the one, but okay. Unique ID. Yeah, I don't know if it's necessary. Let's just try. Let's try. And now, oh, I'm gonna go do the clean again. So I'm just gonna open this one like this, just so that I can launch the cmake clean command. Really? Okay. Really? Okay. So I guess I maybe did something not legal in my file. What else do they do? It's a little different, but not that different. Okay, what if I put public like here instead? Kind of like they do. Basically, I'm just doing exactly like they did with the tiny USB thing. Oh, is it about the standard of the version or something? No, that should be fine. Okay. Yeah, let's try this instead. Here, what if I try to clean now? Okay, it's been cleaned and reconfigured. That's good. So now I should be able to just launch, whoops, here. Hello? CD, oh, because I restarted it. So CD hello world. And I can launch do. So let me just put my Pico ready to receive. Okay. Oh. Nope, something failed. World building failed. Okay. And then there's a huge command. Then blah 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 blah. In file included from hello world at line 5. Debug error redefinition of debug led in it. Wait. Can I not overload functions in C? Wait, can I literally not? You have to be kidding me, right? I can't? Really? Where is it? Is it, oh, it's in debug led, right? So I literally can't, huh? Okay, let's say equals 0 then. Not here. I mean, well, it could be equals 0 here, it's fine. But especially here then? This is equals 0, so if I don't define it, that's what it does then. Okay, so let's recompile. Let's send the code. Oh, you have to be kidding me, right? Let init, did you mean debug led update? Why? What are they talking about? Wait, what? Can I not give default values to... Wait. I'm really used to C++. I'm not used to C all that much. Wait. Can you... give... Let's like give... default arg value in C. Really? Wait, what? Oh. Well, no, it's not really possible. Okay, it's... Nope. You can't do that? Now, can you... what was it? Oh yeah, can you overload functions in C? Oh, wow. Okay. I guess you can't. You know, that's probably why there was no argument here in the first place. So you know what? Never mind. You're gonna have to call set interval for real. When hello world C. So yeah, it's gonna be nothing here, and then debug led set interval 500. Okay, so now it should work. Yeah, let's just do this. Make sure it works. Compiles. Warning. Okay. And it did copy. It was still ready to receive code. Okay. Okay, yeah, I don't really care about that. Yep, and it's blinking. Okay. Well, well, well. Okay. And now, if one of them was pressed, I can... let's just put back those things on. I should probably, just for flexibility, always add the brackets. It's easier to add code. So here, I can change the interval. Set interval to like... Maybe I can... No, it doesn't really matter. Like a long time. When I do this, it's not gonna work, right? Yeah, it's not working because the Pico is not ready to receive code. It should be. Okay, and now if I... Yeah, it doesn't really work. Okay. Just give me a quick second. Okay, I'm back. Okay, so let's write some interesting code. Like actually interesting. Let's declare a 2D array. Oh yeah, so... Wait, so if I go... Oh yeah, I can just write characters. Okay, so let's go like int characters, or maybe not int, maybe like char. Letters, something like that, which has this, well, can I just say is equal to something and then write the array, and it's gonna have a default size like this or something. Okay, let's look at the Pico. Whoops, sorry. Okay, let me just really quick put this in good view. Okay, so we're gonna write the letters that we want to be outputted by the different connections. So like 1, oh, or hey, you know what? Instead of, no, I guess I can define 1. So let's say, yeah, let's say 1 Q. Whoops. Oh yeah, I want them all to be characters. So let's just, you know what? Let me just copy this a bunch of times. 2, 4, 5, and 6. And then let's just keep on the next line because it's going to be easier to recognize like this. And then 1, 2, 3, 4, 5, and 6. That's the second row. Then there's 5 on that row. So 1, 2, 3, 4, and 5. Then final row has 3 of them. Okay. So let's say 1 and 2. That was like, so let's go with the capitalized. So QW. Then here is, what is it? F? That's F. P. B. There's A. R. S. T. G. And there's Z. X. C, D, and V. V right here. And then here the direction keys. They can be okay, let's just go with what's written on them or something. So like this. And then this is a space, I think, but let's just, do I have like a, it's a little arrow that goes this direction. And then like a, it's not a V, but it's a little symbol that points down. So my dog is barking. Okay, let's say a small V on that one for the arrow. Pointing down. It doesn't really matter. I mean, 1 could actually be this if I really want to represent the characters, and then here it's like that. Okay, so it's pretty much the same characters here as is written on my actual keyboard. Okay, so that's pretty good. I could probably even like place them, you know, correctly too, but you know, this is fine. Okay, these are the letters. So if I go car, letters, just array like this, does it know? Oh yeah, it knows. Okay, that's good. So I don't have to precise. Now, I can kind of use this as a mapping to output stuff. So when they're pressed, instead of printing hello world, I could instead print something like person. Is it a C for a character? I'm not too sure. I don't remember the formatting just off the top of my head. So if I just go here, I can just go C, format string, format specifiers for character type. Okay, so I was right. So character C, then \n, and here I can just give, oh yeah, so instead of putting it here, by the way, instead of doing a was pressed in the first place at all, if I don't break, instead I just go, if it's pressed, then you print, like letters at position, like I-2 or something. Jesse. Okay, something like that. This should print stuff to the serial monitor corresponding to the letter that I'm, you know, connecting to the thing. Yeah. By the way, debug led set interval 0. I don't even have to set it. And I remove the update. This way, if I just init and never update it, it should always be on. This way, I'll just know that it's on, basically. It's ready for the code and whatnot. And here, sleep, I can sleep like... yeah, 100 is fine. Okay. Let's try. I should be able to write to the serial monitor a bunch of characters now. So they're not real, like, key codes that I would be sending if I was emulating a keyboard, which I will be doing with tiny USB. Maybe later, maybe next time, we'll see. But at least I should be able to write them to the serial monitor. Of course, since my circuit for my switches seems to not be working right now and I need to debug that, I will just use my crocodile crimps to like connect, basically to send voltage directly to the pins. Okay, so let's just upload that to the Pico and see how we're doing. First off, let's just not reset it, just, yeah, okay. So it builds correctly. So let's try it for real now to upload it. Okay, I'm sending the code. Yeah, as I said, the debug LED is always on now. So let's try with one of the crocodile crimps to just, you know, short circuit stuff. Okay, so I'm just gonna press a random one and it should go to the serial monitor. Now the serial monitor doesn't seem to be working too well. It seems to disconnect easily. Oh, what? Oh no, I forgot. Oh, I forgot. That's stupid of me. So, oh, I'm kind of dumb here. So, gosh. You know what? Let's remove the debug LED code. Because that's annoying. I'm gonna remove the tiny USB stuff. Or maybe, you know what? Let's remove device, I guess. And maybe unique ID. Let's try. Because, okay, basically, when you configure your device to use tiny USB uses the USB cable. So you can't use it for serial communication at the same time. So what I'm kind of trying to do is trying to just get what I really need. So that maybe it doesn't like deactivate my serial communication. That's why I don't appear on a COM port, serial communication port. So let's try to send a new code now. you know, it's fine. Okay. Now, am I can? Oh yes, yes, yes. Start monitoring. Okay, okay. Now I'm gonna use the crocodile crimps and try to connect stuff and see if it prints. Ooh, can you see this? A bunch of X's. So I pressed the last one, which apparently is X. Yeah, because I remember that 4 from the top was G. Then the next one was a ground. Then the next one is Z. And then the final one is X. So it is writing the correct character to the serial port. I don't know if I could make it bigger. Nah, not really, right? Okay, but the serial monitor, it's working. Okay, so let's try them in order now. Okay, okay. Yeah. Nice. Oh, why is it doing Q and W? Did I solder them together? Whoops. Wait. Okay, I think I can use what's happening here with my crocodile crimps to debug where the current goes and what's problematic. Maybe. I'm not sure. Whoa, why is it not? Stop monitoring? Start monitoring. Okay, that's good. So the first one seems to be okay. See, it just keeps disconnecting. I don't understand why. Oh, okay, it's because it's COM1. I want COM4. So Q is fine. W does F as well, which I don't understand. I guess they're soldered together? Or is my crocodile crimp touching both? Oh yeah, I guess because sometimes the solder on top of the header is a little irregular, so like makes the crocodile crimp kind of twist a little bit and touch the other pin next to it. So. Oops. Start monitoring. Now I'm at P. Yeah, it should be fine. Then it's going to be B. Oh, is T not working? Oh. Okay, they all work. Some of them are a little more finicky to get, but I think it's just the contact with the crocodile crimps and the little pins. So they all work when I send current directly to the header of the microcontroller. So the code here works, basically, is what I just tested. Also, I guess I tested the solder on the headers of the microcontroller themselves, but that's been soldered for a long time. I used a lot of solder, and I made sure a long time ago that it worked. So there really has to be something wrong with my circuit somewhere. And I don't really think that it's got anything to do with... No, I can't say that. I don't know. I can't advance my ideas too much without testing. Because basically, what I just tested was... Like, basically, I made sure that no two switches... Oh, it's a little off center here. I made sure that no two switches are soldered together after, like, this... Well, two switches, but basically after the switch, right? After every switch, there's a wire that goes from the switch to the pin. So I verified that none of these wires like after the current, like I verified that none of these were soldered together, right? Because if they were, I would have gotten multiple letters. When I thought W and F printed at the same time, that's why I was wary of this, because I was trying to verify did I, basically solder something incorrectly, let's say past the switches. Now, it's still possible that I soldered something incorrectly in the sense that maybe it broke off and it's not soldered anymore, but, no two after switches, let's say, are soldered together. So that's pretty good. And everything that's before the switches, they actually need to be soldered together. So the problem there is possibly the connection is broken off somewhere. But like the fact that even G is disconnected, like here, if I press G, yeah, I should need to open the serial monitor to see this. But if I press G, like nothing's happening, right? So if things were electrically correct here, I would expect that when I press these keys, it's being received by the microcontroller. The microcontroller would perceive that as current being sent to it. Again, I think it might be because I need a pull-up resistance. Possibly. I will test that, I guess. And otherwise, I don't know. Can I test it like right now? I mean, possibly. I don't know if it would change anything. Yeah, I'm not sure. The thing that's really annoying to me is that when I tested things on a breadboard here, like originally, I didn't use any pull-up resistance. The circuit was a little bit different because I had rows and columns, but it's so weird to me. It really feels like I shouldn't need any pull-up resistance. What else could be the problem? I mean, since even the G is not working, I would be highly surprised if like all of the wires coming from the switches to the pins are the problem. So I guess the logical conclusion would be that there's something wrong with my soldering of the very first wire that goes to the switch with the letter G on it. But I really checked it out like when I opened the board because I really thought it could have been the problem. I'm not too sure. There's no music anymore, but I don't know. I think I'm probably gonna stop here, and then I'm just gonna on my own do the debugging of why does it not work. And I might also try to, the whole like USB descriptor and whatnot and TUSB config and stuff like that. I did figure that out last time when I was testing out stuff on a breadboard months ago. So maybe I'll just check what I did with these projects. They're not even on this session because they're not part of my modules here. I actually wanted to make a little module for that. So maybe I'll just try to make a module from this. And next time we're going to be all set up and ready to use USB communication and actually send keys to the computer. Maybe I'll do that by myself. But mostly I really want to make sure that I can detect the key presses, the switches when I press them. It's really important that it's being detected by the microcontroller. Otherwise, I'm just stuck with my little crocodile crimps, sending my current manually, and it's fine to test the board itself, but I'm not going to be testing my code like that forever. So yeah, see you next time. We did some pretty good stuff today. We saw that we could do code, that it was pretty much like easy to do, and it's going once the circuit actually works, we're going to be able to advance pretty fast, I think. So I'm satisfied with what we did today. I'm a little sad that the circuit doesn't seem to be working still. And yeah, I'm going to be doing research on my own. And yeah, eventually we're going to have a really good keyboard. See ya. Thank you for watching. Have a nice one.